So, good afternoon, all. For today's Biomedical Signal Processing Lab 9, the aim of this lab is to design of digital filter using window method. So, let's start. First is a filter. What is a filter? It is a frequency selective network that passes a specific band of frequencies and blocks signals of the frequency outside that specific band. The filters are mostly classified as low pass filter. It allows the low frequency to pass and blocks high frequency about the cutoff frequency. Second is the high pass filter. It allows the high frequency to pass and blocks low frequency below the cutoff frequency. Third is the band pass filter. It allows the frequency to pass in a band and stops the rest of the frequency to pass. Fourth is band reject filter. It rejects the frequency to pass in a band and allow the rest of the frequency to pass. So next is FIR filter. The FIR stands for finite impulse response, and the FIR filter is one of the two main type of digital filter used in DSP application. The FIR filter has an impulse response of a finite period. As a result of it, it settles to a zero in finite time. It acts as a signal conditioner, which means it allows the AC component to pass and blocks the DC component. That's how a FIR filter block diagram looks like. There is an input signal Xn. When it passes through a system which is having a in system function of H of n, it will generate a Y of n. Is the logic. Next is the logical structure of a FIR filter. How a FIR filter looks like. The FIR filter is used to implement all types of digital frequency responses. The FIR filter includes multipliers, adders, and delays to create its output. Here how a delay is to delaying a function, and multiply is to multiplying the sum with a specific constant value, and adder is to add on all of them, and combination of all these three makes a FIR filter logic. Next is designing method for FIR filter. It is the process of choosing the length of the coefficient of the filter. The response of the filter are classified into three types of bands, which are pass band, stop band, and transition band. Although in ideal phase, it looks like in a square step size function, but in real in practical application, it's a sine wave which transit from the pass band to the stop band, and in between there is a transition band which starts from omega p to omega g. Next are Windows method. So there are some Windows method that is being used for this FIR function, this filter. It is a finite duration sequence that is used to shape the ideal impulse response into a practical response. The Windows helps in reducing ripples in the pass band and stops of the stop band of the filter. The window help in achieving the desired transition from the pass band to the stop band. The common window functions are Hanning, Hamming, Bartlett, and Blackman. Here are how a window function can alter a signal. Here we have in the first figure we have a Hanning window, and how when it is being overlapped with a sinusoidal function, it looks like after and its frequency response. Similarly, for the fifth figure, we have Hamming window, and its frequency response, and when it interacts with the sine signal. Next is a Bartlett window. Its the frequency response, and seventh is the Blackman window and its frequency response. All of them are quite different from each other because of their windowing function. Here are my references for today's presentation. Thank you all.